Okay, we're back again. CLEP, Calculus Practice Exams that I found online. Link also in the description. We are going to finish off this one, getting back into it with number 56 there, where f is the function e to the power of 3x, and g is just x cubed. So at what value of x do these two equations have parallel tangent lines? What do we mean by tangent lines? We mean a line that matches the slope at that point. And what do we mean by parallel? We mean that the slopes are going to match. So basically saying at what value of x do these both have the same slope, or at what value of x does the first derivative of this and the first derivative of that equal each other. So we are going to work with it on that basis. We have f of x equals e to the 3x, and the other one is g equals x cubed. Okay, so we know that the derivative of this simple power rule, the 3 comes down, 3 minus 1 is 2, so that's 3x squared. This one is a little more complex. We're going to have to use the chain rule here. So again, the chain rule, and don't get confused by the f of g of x is different g. Ignore this g. This is just a theoretical g. When you have the composite function g of x inside the f of x, the derivative of that is the derivative of x with the original g inside times the derivative of g. So in this case, the f portion is e to the x. We know the derivative of that is itself. Special case, just got to remember it. And the portion inside there, the g, is 3x, right? The 3x goes inside that to get this. And the derivative of 3x is just going to be 3 power rule, x to the first, bring the 1 down, subtract 1, x goes away. Okay, so filling it back in for that, the derivative of the f is the e to the power of the original inside, so it's still just the 3x, times the derivative of the g, the inside. So that's going to be multiplied by 3. And we'll just rewrite it more nicely, bringing the 3 out in front. So now we have that one, and we have that one. Those are the derivatives of the equations we were given. And we want to know for what x are those equal. So there's not going to be a quick and easy way exactly to solve that by hand, but we get a hint. We get all those decimal values there, which means this is a prime candidate for using the calculator. So we are going to graph those two equations. So the first one is 3 times, and then the e is there. It's the second function of natural log. We're going to do e times, or to the power of 3x, and the other one is simply 3x squared. And we're going to graph that out. and it's all kind of small and tiny. Let's zoom in so maybe we can see that better. Okay, we can trace over to that. Looks like it's going to be somewhere around negative 0.47. Right, and if we look at our options here, pretty close to that is letter C. We can double check that if we want. Go into the calc menu, intersect selection, first curve, you just hit enter. Second curve, we only graph two of them, so only two choices. And then guess, we're already pretty close there. Turns real quick, negative 0.4839. So yeah, our guess remains, or our answer remains this one at C. So that's that. And 57, what is the derivative of, so this notation, that's the inverse sign, also known as the arc sign, where if the sine of theta is some number n, whatever, then the arc sine or the inverse sine, whatever notation you want to use, of n is equal to that theta. So it's just the inverse operation of that. So they want you to do the derivative of this, and this is one of those, you either know it or you don't. It's a bonus if you can memorize these, but it's probably asking a little much. So if you were to go look at a reference, if you did happen to have this memorized, then we would know that the derivative of the inverse sine is 1 over the square root of 1 minus x squared. And again, bonus points if you take the time to memorize those, but it doesn't show up on the exam enough. Based on this, it doesn't show up enough to take a lot of extra effort to memorize those. Memorize everything else that you need to know first. Memorize the chain rule, the product rule, the quotient rule. If you have extra time to memorize things, then maybe memorize the derivatives of the inverse trig functions. But knowing that, let's just finish going through with it, because that's the 5x. So if it would be the 5x in there. Right? Or the derivative. So again, at this point, chain rule stuff, common chain rule, where we want the f. The f is just the original, that stuff. Well, that's the f prime. The f is the sine, the inverse sine. And the g is the 5x. So the derivative of the g is just going to be 5. So by typical chain rule, the f of the g times the derivative of the g. So it's going to be all of this times 5. So you have the original, the 5 on top, square root of 1 minus 5x squared. Or if you wanted to actually do that square out, 1 minus 25x squared is what that turns out to be. And that is answer D. But again, to even get there, I demonstrated how you would do the chain rule for that, but you're not going to get there unless you know right off the top of your head what the derivative is for the arc sine. There's not even a good way to derive that. You either know it or you don't, and I'm going to assume that you're not, because that's a little more to memorize than you probably really want to memorize. Again, if you have extra time to memorize extra things, but that's like a last priority memorization there on the inverse trig function stuff. Okay, number 58, the population P of the bacteria in an experiment, just some population, doesn't matter, it's bacteria, it's population, and it's growing according to the equation dp over dt. That's the slope. It's derivative, it's a slope, equals k times p, where k is a constant and t is measured in hours. You note the trick here is that it's a derivative per t, but t is not part of the equation here. This is that goofy exponential growth stuff again. So you could go through a lot of complex stuff to derive this into a version you can work with. Or if you just remember the proper formula, the end formula for exponential growth, where p in terms of t is p naught or p0, p sub 0 being the starting population, times that e to the exponent kt. Now we have t as a part of it. So if you can remember that and get that in there, now we're saying the population of the bacteria doubles every 24 hours. So what is the value of k? So it doubles. So the easy way to think of doubling is it goes from 1 to 2. You could say 2 to 4, you could say 3 to 6, but just 1 and 2 is real easy. So your starting population at t equals 0 is going to be 1, and it doubles every 24 hours. So at a t of 24, it equals 2. So from that, we get p of, well, if t is 24, we can fill things in. 2 p of 24 equals p sub 0 is the 1 times e to the power of k times the t, that 24. So we have, simplify a little bit, e 2 equals e to the 24k. So now, again, recall the when you have an e and you want to find what's in there, remember that the natural log and e are opposites, in that the natural log of a equals b is the same as saying e to the power of b equals a, right? So if we take the natural log of both sides, natural log of 2, natural log of e to the power of 24k, that essentially cancels out. You're left with natural log of 2 equals 24k. This is really not quite similar to most of the other things that we've been doing, but on the basis of that, this is what we do to solve this one, assuming you can remember these different things. It's one of those, if you don't remember it, you skip this one, and just rely on the more common things that we've learned and their application to the other types of questions. But we're solving for k, so the natural log of 2 over 24 equals k, and that's where we bring in the calculator. I still have okay, so the natural log of 2 divided by 24, 0.0288, and in our selections, 0.02, it rounds to 0.02888, rounds to 0.029. So that would be the answer there. So if you can remember that exponential growth type things are going to look like that, that'll help you out. If you can't, that one is just going to get skipped. But that would be how we solve that if you're remembering all the things you need to remember that are relevant to that. All right, moving on then to number 59. The graph of some function f is shown in the figure above. What is the value of the limit as x approaches 3 for not the function as drawn, but the function times 2 and then subtracted from 4? Oh, okay. So this is one of those interesting ones where you have a hole in the graph and then they fill it in up here, so it's a mismatch. It's not continuous. And we've had some questions where you have to make a note that the value they filled in is not filling in where it's supposed to be filled in. But we're just talking about the limit as x approaches 3, and so we are talking about right here, where the fill-in should be, not where it is, but where it should be, right there. So start off by noticing that the limit as x approaches 3 for f of x is just right at that point, x equals 3 and the y equals -2. So that would be -2. And then if we multiply things by 2, so the limit of x approaches 3 for 2, well, -2 times 2 is -4. Okay, so now one more step. The limit x minus 3 of 4 minus that So now we've added in the 4. So that would be 4 minus what we had, right? We added in the 2, 2 times negative 2 gives us the 4. And now we're taking what we had, subtracting it from the 4. And 4 minus a negative 4 is just 4 plus 4 is equal to 8. So we start with what we know in simple terms and then manipulate it up to match what they had. That looks complicated, but yeah, all they're doing is taking what it is at face value and then doing a couple simple things to it, multiplied by 2, subtracting it from 4. So negative 2 multiplied by 2 and then subtracted from 4 just takes us to 8. And 8's right there, selection E. That is indeed the answer. And that one's actually pretty simple compared to what it looks like, really. One of those, and again, just take what you have, break it down into pieces, take it one step at a time, and it'll get you there. Okay, number 60. Last one for this test. And then we'll, next video, we'll go on to the other one. During a snowstorm, the rate in inches per hour at which the snow falls on a certain town. Okay, here's the function. R of t equals the negative cosine of t minus 0.9t plus 3, where t is hours, and we only care about t's between 0 and 4. So based on the model, what is the amount of snow in inches that fell on the town? So if you're thinking that this is going to be a definite integral, you're right. The equation is telling us how much snow is falling at any given time. And then to add all those together, we want to find the area underneath all that. And that's a grand mess, but because this is the calculator portion of the exam, we just punch in negative, and the negative there, negative cosine of x, we're on the calculator, so we use x instead of t, minus 0.9x plus 3.0. 0.0 doesn't do anything at this point. So we go to the graph, see what that looks like. It does a thing. And it looks like it actually cuts off at 4 because that's where the equation goes negative. So there couldn't possibly be anything beyond, well, that would be negative if we started counting beyond 4. You can't have negative snowfall. So definitely cuts off at 4. And we don't have to do anything further here. It's all set up. We just go into our calc menu and take the definite integral function there. And it asks us our lower limit. It's already at 0, so we can just hit enter. Upper limit, I didn't change the zoom into anything that would let me arrow over to 4, but I'll just type in 4 and hit enter, and it thinks a little bit and gives you 5.556, etc. And if you just round that to one decimal point, one decimal place, that's going to be 5.6. That is indeed answer D. And that's really not even that tricky. Just throw it into the calculator and run it through. Pretty easy. We love it when they are that simple. They're definitely not all that simple. Okay. That's it for that test. And as I said, the remainder of the videos will be on that other test, that second test that I also found, found 2 different tests. So it's like, all right, let's run through both of them. So it's going to be the other test in the remaining videos. See you then.